Hello everyone, this is Omka here. So I hoped you checked my video on Arduino DAC and you know you got some insight into it. So you have to be updated about this channel. I hope everyone is updated. So coming to the topic we are going to see today. So we are going to discuss you know the properties of Twiddle factor, then the properties of discrete Fourier transform. Okay, so first we will begin with the properties of Twiddle factor. Okay, properties of Twiddle factor. So if you can remember what is meant by Twiddle factor, omega n is equal to, or wn is equal to, e power minus j 2 pi by n. So this is your Twiddle factor. I know most of you might not remember things because it has been done way before. So for this Twiddle factor, we are going to discuss about two property. The first one is the periodic property. Periodic property. Then I'm going to discuss about the symmetry property or symmetric property. Symmetry property of Twiddle factor. So let me go to the first property, which is meant by periodic property. So according to the statement, Wn of k plus n is equal to Wn of k. So this is your periodic property of Twiddle factor. Wn of k plus n is equal to Wn of k. So this you have to prove using some properties. So this, if you can see, Wn of k plus n, it is in the form of a power m plus n. So how can we expand this one? A power m plus n is equal to a power of m into a power of n. Similarly, we can take this one, omega n of k plus n is equal to omega n of k into omega n of n. So now, as I said, if you remember Twiddle factor, W of n is equal to e power minus j 2 pi by n. So let's substitute that. E power minus j 2 pi by n. So we have k here. So multiply by k. Here e power minus j 2 pi by n. What do we have here instead of k? It is n. So n. So now this n and n you can cancel. So what is remaining? E power minus j 2 pi, which is equal to cos 2 pi minus sin j 2 pi, which value is equal to 1. So what will be remaining here? E power minus j 2 pi by n. So this k I can write it like this. So this is nothing but omega n of k, because omega n is equal to e power minus j 2 pi by n. Whole power of k is omega n of k. Therefore, omega n of k plus n is equal to omega n of k. So this is the periodic property of Twiddle factor. So let's see once again. So we know that Twiddle factor W of n is equal to e power minus j 2 pi by n. So we have to prove two properties. The first one is the periodic property and the second one is the symmetry property. So according to the periodic property, Wn of k plus n is equal to Wn of k. So this is the periodic property we have to prove. Simple. We know from basic mathematics that a power m plus n is equal to a power of m into a power of n. Then substitute for the Twiddle factor and right hand side term is equal to 1. What is remaining is omega n of k plus n is equal to omega n of k. So this is the simplest derivation for Twiddle factor, which is the periodic property. So now what is the second property? Symmetry property. So let's go to the symmetry property. Okay, let me take a new sheet here. Okay. Yeah. So I have to prove the symmetry property of Twiddle factor. So what is the statement say? Symmetry property. So according to the statement, Wn of k plus n by 2 is equal to minus Wn of k. So this is the symmetry property of Twiddle factor. Wn of k plus n by 2 is equal to minus Wn of k. Same thing. So in the previous property, how we have proved, the same technique has to be followed. So there we expanded a power m plus n is equal to a power of m into a power of n. Same thing you apply here. Okay. 1 minute. Yeah. So this Wn of k plus n by 2, how can we write? Wn of k into Wn of n by 2. So now Wn of k I'll keep as it is. So now Wn of n by n by 2. So let's just substitute. We know for Twiddle factor Wn is equal to e power minus j 2 pi by n. Then what do you have here? N by 2. So multiply by n by 2. So 2 and 2 get cancelled. N and n get cancelled. What do you have here? E power minus j pi. So cos pi minus j sin pi. Okay. So cos pi minus j sin pi is nothing but minus 1. So this is equal to Wn of k into minus 1, which is equal to minus Wn of k. So Wn of k plus n by 2 is equal to minus Wn of k. Easy. So what we have proved is, one is the periodic property and then is the symmetric property. So first what we have done, we have taken Wn of k plus n is equal to Wn of k. So a power m plus n, a power of m into a power of n, then just substitute for the Twiddle factor formula and then you'll get the answer. Similarly, for symmetry property, same thing. The statement you have to remember, Wn of k plus n by 2 is equal to minus Wn of k. Okay. So for that, again, expand it, substitute for Twiddle factor and get your answer. So now we have finished with the two properties of Twiddle factor, which is periodic property and symmetry property. Now let us go to the another property for discrete Fourier transform. So now we have finished with the properties of Twiddle factor. Now let us dig in with some of the properties with respect to DFT. So properties with respect to discrete Fourier transform. So the first property, we will see total 4 properties: linearity, then we will see periodicity, then circular time shift, then circular frequency shift. So these are the 4 properties which we are going to see today. Okay. So let me begin with the first property, which is linearity. Okay. So what does the statement says? So DFT of x of n is x of k. So this we know that. And then x2 of n DFT is x2 of k. This also we know. Then according to the linearity property, a1 x1 of n plus a2 x2 of n discrete Fourier transform is a1 x1 of k plus a2 x2 of k. So this is the property, linearity property of discrete Fourier transform, which we have to prove. So let's go slowly, step by step, understand the things so that we can do it in a better way. So all these properties are like quite easy. Only thing you have to practice it until you get that. Okay. So how can we prove that? So we know the formula for DFT of x of n, which is equal to summation n varies from 0 to n minus 1 x of n and omega n of kn. So in terms of Twiddle factor, I have written. Okay. So now how can we prove this one? Okay. So now just observe here. So instead of x of n, you have a1 x1 of n plus a2 x2 of n. That's it. So we have to take the DFT of this one. So how can we do that? So DFT of a1 x1 of n plus a2 x2 of n is equal to, so what is the formula here? Summation n varies from 0 to n minus 1. So instead of x of n, we have a1 x1 of n and a2 x2 of n. So let me substitute that. a1 x1 of n plus a2 x2 of n into omega n of kn, because it's there in the formula. Just here I have replaced that one. Now take this individually. Okay. Summation n varies from 0 to n minus 1 a1 x1 of n into omega n of kn. Similarly, you have to expand it. N varies from 0 to n minus 1 a2 x2 of n into omega n of kn. Now take a1 and a2 outside. So summation n varies from 0 to n minus 1 x1 of n and omega n of kn. Similarly, here a2 summation n varies from 0 to n minus 1 x2 of n omega n of kn. So now what can we do is, so this term summation n varies from 0 to n minus 1 x1 of n omega n of k1 is nothing but your x1 of k. So see this formula here. So just check this formula and see, this term is nothing but x1 of k, and this term is nothing but your x2 of k. So what are the things you have to remember? Just the statement a1 x1 of n plus a2 x2 of n. DFT is a1 x1 of k and a2 x2 of k. So basically you have to remember the formula for DFT of x of n, which is summation n varies from 0 to n minus 1 x of n omega n of kn, and just substitute that for x of n. What is there? a1 x1 of n plus a2 x2 of n, and then expand it and bring it to the proper form to get your answer. So this is the linearity property of discrete Fourier transform. So similarly, we have to see the periodicity property, and then circular time shift and circular frequency shift. So let us see one by one. Okay. Okay. So let me take a new sheet. Okay. Okay. So now periodic property or periodicity property of DFT. Okay. Periodicity or periodic, which repeats with respect to time, means x of n plus n, for example, like a sinusoid, which repeats. Okay. So periodicity, what does the statement say? So if DFT of x of n is x of k, then according to the periodicity property, x of n plus n is equal to x of n for all values of n. This means that like up till n, okay, after n if it repeats, it is same as x of n. So that's the meaning of the statement. So x of n plus n is equal to x of n for all values of n. Similarly, x of k plus n in the frequency domain. So this is in the time domain, this is the frequency domain, is equal to x of k for all values of k. So the statement states that the sequence repeats after n number of samples. Okay. So how can we prove that? So the first one I will prove. The second one is like a homework to you. So you know x of n formula. So IDFT formula, not x of k, x of n. So 1 by n summation k varies from 0 to n minus 1 x of k e power j 2 pi by n into kn for n varies between 0 to n minus 1. So this is the formula. So this cannot be changed. IDFT formula. I hope you remember to get the time domain signal x of n. So now you see the statement. So it's very easy. So you have to remember the formula, you have to remember the statement. Then according to the statement, you can go. So what is there? X of n plus n. So let us replace here n by n plus n. So x of n plus n is equal to 1 by n summation k varies from 0 to n minus 1 x of k e power j 2 pi by n k into n plus n. So now what can we do is similar to a power m plus n, a power of m into a power of n. So 1 by n summation k varies from 0 to n minus 1 x of k. So this one e power j 2 pi by n k into n. So this one e power j 2 pi by n k into n. So this whole term, so n and n cancels. So this whole term is equal to 1. So what is remaining there? So 1 by n summation k varies from 0 to n minus 1 x of k e power j 2 pi by n into kn. Okay. So this looks like your IDFT formula, right? 1 by n k is equal to 0 10 minus 1 x of k e power j 2 pi by n into kn. So this is nothing but your x of n. So x of n plus n is equal to x of n. So let's see once again, how did we get this? Okay. So x of n plus n is equal to x of n and x of k plus n is equal to x of k. So the first one I have proved. Similarly, you can do for the second one. So take the formula for x of k. So normal summation n varies from 0 to n minus 1 x of n e power minus j 2 pi by n into kn. And you can do in a similar fashion. So replace n by n plus 1, then expand it and other term equal to 1. And you will get x of n plus n is equal to x of n. Very easy. So linearity, periodicity and all, it's like very easy. So now we'll see the other two formula, which is circular time shift and circular frequency shift. Okay. 1 minute. Yeah. Let me take a new sheet. Yeah. Okay. So circular time shifting property of DFT. Okay. So first we'll write the statement, then we will understand step by step what to do. Okay. So nothing. First, what we have to do is we have to remember the statement. So what is this circular time shift? What is the statement for that? And accordingly, we have to substitute for IDFT formula or DFT formula. Accordingly, substitute that and get the answer. So let's see how can we do this step by step. So according to the circular time shift, as the name indicates, it is shift in the time domain. So x of n minus n naught whole modulo n. So this is equal to x of k into e power minus j 2 pi by n into k into n naught. This means that if you are shifting in time domain, then the equivalent frequency domain you have to multiply by e power minus j 2 pi by n k into n naught. So this you have to remember. So see the statement circular time shift. Why circular means this modulo n will come, and time shift n minus n naught. So you are shifting in time domain. So what happens in frequency domain? We have to see. So this happens in the frequency domain, which you multiply with the exponential. So now we have to prove this property. So how can we prove this property? So we can start by IDFT formula. So according to IDFT formula, same thing like previous, x of n is equal to 1 by n summation k varies from 0 to n minus 1 x of k e power plus j 2 pi by n into kn. So now what you have to do is, okay, check the formula x of n minus n naught. So replace n by n minus n naught. So x of n minus n naught is equal to 1 by n summation k varies from 0 to n minus 1 x of k e power plus j 2 pi by n k. As I told you, replace n by n minus n naught. So now what you have to do? Expansion. So summation k varies from 0 to n minus 1 x of k e power j 2 pi by n k into n into e power minus j 2 pi by n k into n naught. So just a power m plus n, a power of n into a power of n. All thing, is the same thing only. So this thing, how does it look like? So this thing is nothing but your x of n, right? 1 by n summation k is equal to 0 to n minus 1 x of k, everything is same. So this one is nothing but x of n e power minus j 2 pi by n k into n naught. Okay, so this is nothing but x of n minus n naught. So now take DFT on both the sides. So x of n minus n naught is equal to, taking DFT on both the sides, okay, x of k into e power minus j 2 pi by n into k into n naught. So this is the easiest way, to prove this property. Okay, so similarly, you can use anything to prove. So I have taken the easiest method. You can take Twiddle factor and also prove. There is no harm in that. So only thing, the concept must be clear. So now we have studied this circular time shift. What is this? Shift in the time domain will make you multiply with the exponential. For that you took the IDFT formula, substitute that x of n by x of n minus n naught, and then you had proved. So similarly, we'll go to the last property, which is circular frequency shift. So circular frequency shift. So let's see the statement. What is the statement? And then we can proceed. Okay. So according to the statement, you have to shift in the frequency domain. So x of k minus l. So it's, since it's circular, so mod n. So this is nothing but discrete Fourier transform of x of n e power j 2 pi by n into l into n. Okay, so you shift in frequency domain. So x of k minus l. What happens in time domain? Multiply by the exponential. Okay, so this thing you have to remember, this statement. So now we can prove. How can we prove? According to the statement, x of k is equal to summation n varies from 0 to n minus 1 x of n e power minus j 2 pi by n into kn. So k varies from 0 to n minus 1. So this is your formula for x of k. So this is common. X of k summation n varies from 0 to n minus 1 x of n e power minus j 2 pi by n into kn. So now what we have to do, replace k by k minus l. So put that x of k minus l circular convolution, which is equal to n varies from 0 to n minus 1 x of n e power minus j 2 pi by n. So now, as I told you, replace k by k minus l into n. Now expand it. Summation n varies from 0 to n minus 1 x of n e power minus j 2 pi by n into kn into e power. So minus into minus, it will be plus. So e power plus j 2 pi by n into ln. So just I have multiplied it. So now what you have to do? Just observe this one. So this formula, how it looks? Looks like this, right? X of k. So this is nothing but your x of k into e power j 2 pi by n into ln. So now take IDFT, you'll get x of n e power j 2 pi by n into ln. So this is your circular frequency shift property. So what we have done? So take the statement. What happens if you shift in frequency? So circular frequency shift. You are shifting in frequency domain x of k minus l. So you have x of k is equal to summation n varies from 0 to n minus 1 x of n e power minus j 2 pi by n into kn. Then you substitute x of k by x of k minus l and carry on, you'll get the answer. So all these properties like Twiddle factor property, like periodicity and symmetry, and properties of DFT like linearity, periodicity, circular time shift and circular frequency shift. So these are very important in the point of view of exam. So make sure you study once and do all the do write it once again. Okay. So I think it's time to sign off. Okay.